So we assume here coming into this that you've got Reach installed on your machine, maybe you've worked through the tutorial and you're looking for a little bit more experience. So this challenge is going to teach you how to do kind of a simple NFT raffle. And then we're going to highlight and you can see I've got it linked here, the cryptographic commitment scheme, right? It's kind of big words. We'll get into that. But to start the general program description here is we're going to write an NFT raffle program that functions like a tip board, right? If you don't know what a tip board is, the key thing is that the winning number is already set at the creation of the raffle, right? But we hide that number from other participants while we draw numbers for their tickets, right? If you have seen them before, it's got a little sticker on it, right? Like you buy your tip board, it's got a little sticker with the winning number under the sticker already. So what we're going to do is we're going to automate that process and kind of hide our number under a sticker, if you will, right? So your program is going to store the NFT and a hashed value for the winning number, right? If you don't know what I mean by hashed value, follow that link, right? It should give a random number for Bob's ticket and then reveal the winning number, right? I've added this week because I think it's important to touch on these, especially in these programs. So the purpose of this program is to demonstrate the Reach cryptographic commitment scheme, right? These commitment schemes are very important in decentralized applications as they're used to verify trust and ensure that a participant's commitment to certain values is still true in the program, right? It also uses non-network tokens to help reinforce some syntax rules around non-network tokens, right? So as usual, there's 3 levels here. You can only submit for 1, right? We recommend starting at level 1 and working your way up to level 2 and then to level 3. These programs are designed to get you building from scratch. So please ensure that these are your original work written from scratch, right? So let's go ahead and get into it. Start with reach init here, and the more we do this, the more useful we see.
Right.
Hi, welcome. Go ahead and mute yourself unless you've got a question, and please drop that in the chat, and JP can kind of call those out for me. So first, let's make a new directory, and I guess it's good to kind of talk about where we're at here, right? So I'm in the home path in a Reach folder, right? So if I showed you what was in here, here's your Reach install, right? My Reach install lives here, and then these are all the various project folders that I use, right? So if we wanted to make a new one, let's call it NFT Raffle, CD into NFT Raffle, and then use Reach init to create our index.rsh backend file and our MJS frontend file, right? So now let's go in there and let's open these files up. And if you are not familiar with Reach init, you can actually save these files, make sure they're saved, and then run this from right here. It might tell me that I need to export my connector mode. I'm not sure if I have yet today. But there's Reach init, and that's your boilerplate. It's got your program. It'll get you a couple console logs, let you know you're launching, starting your backends, all that happy stuff. Okay, so we know that runs, right? So let's get out of there and let's start working through what the program description is. So we're going to use 2 participants for this NFT raffle. And generally speaking, the deployer should deposit the NFT, set the amount of tickets that we're going to sell, and then pass in a winning number, right? And the role of the attacher is just to draw a number, right? We're just going to give them a number, right? And then at the end of our program, we'll compare those 2 numbers and transfer accordingly, right? So the first thing we're going to do is use launch token to create a 1-of-1 NFT, right? If you're not familiar, follow the doc there for launch token. The deployer should be responsible for this, right? And then we want to publish some of that information to the blockchain, right? Then we're going to have the deployer pay that NFT into the contract, and we're going to ensure that Bob's account uses token accept to accept this new NFT, right? So first, let's get launch token implemented here, right? So launch token is a standard library function that we have that allows us to create a token inside of our contract, right? So we're going to go right under here where we've got launching there, right? And I always like to include what we're doing so that we can see it, right? So let's just say like creator is creating the testing NFT, right? And then let's actually create the NFT, right? So we said it's launch token, but it's going to store its something, right? So we're going to call it the NFT, right? And we're awaiting the standard library function of launch token there. It takes in the account of the person who's responsible for launching this token. Remember in the notes, I said that the deployer should be responsible for that. That's Alice, right? What are we calling it? You call it anything you like. I'm going to call this one the Mona Lisa, right? What is its symbol? Symbol is going to be NFT. And then there are several optional arguments to this here, but we're just right now going to use supply, right? So what does this do? This launches a token with Alice as the creator, calls it the Mona Lisa, gives it a symbol of NFT, and then tells us that there's a supply of one, right? Okay, that's great. So we've launched the token, right? And now we need to, well, we're probably going to need to send some information about that to the backend, right? So I like to use a parameter object for this, where we just say NFT params. Then you can add whatever you need here, right? So like, we want to know what the ID number is. Well, we can just use the NFT.id to return that. And then the other thing that we're going to need to know here is how many tickets are we selling for this NFT, right? Let's call it num tickets. Let's just hard code that to 10 for right now, right? So here are the parameters we have, right? And here is the information we're setting in those parameters, right? Well, it's a new token, and we need to make sure, especially if we're running on Algorand, that Bob has agreed to accept this token, right? Bob needs to opt into this token, right? So we need to await Bob's account to token accept. What is he accepting? He's accepting the ID, right? But to reference that ID, we need to say NFT params dot NFT ID, right? And that'll pull from this object and give us this ID number, right? So now we've got in the front end here in our MJS file, we've got the deployer is responsible for launching that token, right? And then we've ensured that Bob has token accepted. The last two things we need to do here are backend functions, right? We need to publish the NFT ID, make sure to declare it a token. Token is a special data type in Reach. Make sure you're very familiar with that. And then have the deployer pay that NFT into the contract, right? So these are things that happen in the backend, right? So let's go to the backend here. And how are we going to do this? Well, I usually like to create a function that we call start, like whatever you're doing, right? Start doing the thing, right? So if we're starting a raffle, what is it? Well, it's a function, right? It's not going to take in any arguments. And it's going to return the object that we've declared, right? It's going to return that object that we've declared in the front. And what was that object? Well, it had NFT ID. What type is that? Well, we said it was a token type. Okay, that helps until it doesn't. So it is a token type, right? And then we said that there's a number of tickets, right? And that is an unsigned integer, right? So here is the definition of that data that we're sending to the back end, right? We're going to allow Alice to say, hey, send me that data, and then we'll store it in the smart contract, right? Or we'll store it in the backend file, right? So Alice is going to start Raffle, right? So how do we do that? Well, probably right after here where we, init, remember, is like, let's start stepping through the actual steps of our program. Everything above here is defining the data. What is the data? Well, number of tickets is an unsigned integer. But past this init, we're actually going to start doing things, right? We want A only, right, to tell us information about this, right? So we say A only, right? We called it start raffle, right? So we're going to say const, and remember we said it was an object, right? It's going to give us the NFT ID. It's also going to give us number of tickets, right? And then that is in the start raffle function, but it's a front end function. So we need to interact with that function. We need to interact dot start raffle, right? It takes in no arguments. Now, this is a good point to stop here. So invalid binding in part dot only NFT ID. Secret identifiers must be prefixed by underscore. Okay, that's important. We're going to come back to that later. But for right now, yeah, I did mean declassify. So let's go ahead and declassify that information, right? What did Reach just tell us? It says, well, we're allowed to have private values, but we need to tell Reach about those private values, right? So now we have the NFT ID and the number of tickets, right? Well, before we're allowed to use those back here, we need to publish those to the blockchain, right? So here's NFT ID and here's num tickets, right? So now the contract knows what these values are and has published them to the blockchain, and we can use these in our program now in the backend file, right? So what was the other thing we wanted to do? There was one more we wanted to do, right? Because we've published the NFT ID, declared it as a token, and now we want to have the deployer actually pay that NFT into the contract, right? Well, your intuition probably tells you to do so here, right? .pay NFT ID, right? But because it's a non-network token, we have special syntax for non-network tokens where we need to say 1, comma, how many of them? There's 1. What is it? Well, it's NFT ID, right? Now, intuition brings up this error, right? We try to pay here, but what is this error telling us? Token paid on constructor, which is not possible because the contract does not yet exist and therefore cannot receive tokens. This is an important feature in Reach. This publish actually launches our contract. So we can't pay any tokens into it until it's been launched, right? So what are we going to do? We're going to take this out, right? We're going to say publish our information, launch our contract, commit to all of that, right? And then we can say a.pay, right? So I'm going to say that right here, a.pay, and we are going to use this more than once, the number of NFTs, right? So I'm going to create a constant for that and just call it amount, right? Generally speaking, if you do anything, like if you're using a value more than once, you should probably say const amount equals 1 so that you don't have to keep typing 1, right? You type a constant because you could get into a place where you accidentally type the wrong number. So at least this way you're bound to the same number. Now, this is going to tell me I'm not in the right step. So we're just going to put us in the right step for now. Great. So now we've paid the NFT into the contract. So the contract holds the NFT now, right? That's great. So that's your bullet, right? We've accepted, we published, it's paid into the contract. Now let's have Alice declare a hidden winning number. Hidden is the key word here, right? Because as soon as we send that value to the back end and we publish it, it's public. I mean, if you've heard any of our other lectures and such, we say that everything is visible to the blockchain at all times. Okay, that's great. But what if we don't want that value to be visible, right? This is where we talk about the cryptographic commitment scheme, right? Be sure you read that in depth when you're going through this, right? And this is going to allow us to hide that winning number, right? So what do we need to do? We need a function that returns us a number, and then we need to hide that number, okay? Well, we know, or we may know, how to create a function that gives us a random number, right? And we are going to need this for Bob as well. So let's create it in our shared functions, right? And what is it? Well, we want to get a num, right? It's a function. It's going to take in the number of tickets, right? Because we need to choose a number between 0 and the number of tickets, right? If we didn't set that where we set out between 1 and the number of tickets, you wouldn't need a number here, right? But we're going to say that it takes in the number of tickets for us to be able to use that as a parameter in the front end, right? So it's called getNum. It's a function. It takes in an integer and it returns us an integer, right? Well, if we're saying this is shared, right, we need both participants to inherit the shared functions, right? So A inherits that, B inherits all shared functions. And now let's go to the front end and let's actually define what the action looks like for this random number, right? So right under here, where we've accepted the token, let's create our shared functions in the front end. And this is where we'll actually describe what it does, right? Get num. Remember I said it takes in number of tickets, which is an unsigned integer. Okay. Well, we need to return that number to the back, but first we need to select it randomly from 1. This is kind of important, from 1 to the number of tickets. So like, okay, well, we're going to call it num, right? We know that math.random gives us a random number between 0 and this number. But how do we make that 1, right? We just add 1 here, right? So that'll take from 0 and go up, right? So the last thing I need to do here is give us a whole number. Remember, math.random will also give us a fractional number. It'll give us a decimal. So if we want a whole number, we need to use floor, right? And then return that number to the backend, right? So here we're saying, give me a random number between 0 and the number of tickets that has been declared, right? Add 1 to that. So now it's between 1 and that number of tickets, right? And that's the 0 index that we deal with in programming all the time. So now we've declared the function in the back end. We've said what the data is going to look like. In the front end, we've actually defined the functionality. Here's what it's going to do, right? So now let's talk about how we retrieve that here in the back end, right? So we've already got A only doing something, right? It's going to get us this information. Let's have them get us more information here, right? Like maybe this is where we return that number, right? So we're going to call it winning num, right? And this is the difference between, when I call it like a tip board raffle, between like a regular raffle, right? A regular raffle, you give everybody tickets and then you select a winner. In this program, we're giving the winning number already, and then we're hiding it, giving out all the tickets and then revealing the winning number, right? So here we're going to say winning num equals interact. Remember, it's a front end function, so we need to interact.get num, right? We're going to pass it in what we've already said is the number of tickets, right? Now, we're going to get an error here. Remember, it told us that if we want a secret identifier, we must prefix the variable, or in this case, the constant, with an underscore. Okay, we can do that. Now, this underscore tells Reach we want this value to remain private. You notice we did not have to declassify this value. This value is still hidden under winning num, right? And I've linked in the doc here to the tutorial page where we talk about in depth what the steps look like to do this. So I'm going to touch on them kind of briefly, but walk through them and describe them as I do them. So we've sent this number from the front end to the back end now, and it's stored in a secret value in this underscore winning num, right? That's great. So next, what we need to do, and this falls in with Reach's cryptographic commitment scheme, right? Is we need to commit to this value. We need to say, like, make commitment, right? We need to make commitment to this value, right? We need to interact with winning num to make that commitment, right? But what is that going to return? Well, in Reach, this returns a couple different values. Now, it's going to give us what we call our commit value. Now, I like to keep this with commit, whoever's commitment it is. You may have multiple commitments in a program. If that's the case, call it whatever you like. Commit A. And then this is in a very important value in these hashing schemes, in these cryptographic commitment schemes, right? Is the salt value. It sort of goes along with your commitment, right? And it's another value that we use to kind of tie to your actual value and then verify that they are the same at the end, right? So it's very important that you also keep this value hidden, right? So now we have a hidden value in winning num, right? We've made a commitment to that hidden value, and we've stored that commitment inside of these values, right? Commit A and salt A, right? Now, what do we do with that? Well, we still need to publish this value, right? We need to publish the commitment to it. So let's just call it commit A, notice without the underscore, and then we're actually going to declassify commit A, the hash value, right? So this allows us to declassify the commitment as opposed to the actual number, right? That's very important. That's very important, right? So now what do we need to do? Well, now we need to publish that commitment. So we'll just add it in here, right? And remember, we're storing it inside of this value. So we can just, without the underscore, we can call it commit A. So again, we have stored this value, this private value here in a commitment value. And now we're allowed to publish that commitment value because that commitment value it's no longer the number we have under there, right? The number that we're trying to hide, right? So part of what we want to do is display what this looks like, right? I want to show you what an actual commitment hash looks like. So we're going to say A interact with a function I'm going to call C hash, right? So that it actually shows us what that commitment value looks like in the front end. Okay, well, if I'm doing that, I need to declare this also a function, right? Typically, I think we can keep this in just Alice's, because after she creates it, I just want to show what it looks like, right? So C hash is a function. Now, we might not know what this data type is, right? What if we just guessed? What if we thought it was an unsigned integer and it's going to return null, right? What if we just guessed? Yeah, that's not the error I was looking for, but it's also an important error to show you. Okay, what does it say? It says, let me pull it back up here. Random is not a field of Alice's interaction interface. We're not using random. What do you mean? We are using random. Only because interact is stored within has random, right? So you've seen us import this before. It's necessary in this case so that we can use that interact function, right? Now this is the error that I wanted to see, right? So now we're allowed to use that interact function. I want to display it to the front, but I'm not really sure what type it is. So I just guessed. I just said it's an unsigned integer, right? These types are mismatched. Expected uint, because I told it to expect that, but we got digest. Oh, that's interesting. I wasn't aware of what a digest type is, right? If you search in Reach, you'll find what digest types are. And that means that I'm going to go up here and change this to digest, because now I know that our commitment is a digest type. It's not an unsigned integer. It's a digest type, right? So now let's go to the front end and like actually C hash. Like let's actually implement the functionality here that is C hash. Yep. So let's go to the front here and let's say Alice. Remember, if just Alice is going to do it, it goes here, right? Alice's interact object. If just Bob's going to do it, it goes here, right? So if just Alice is going to do it, well, we already have shared functions, so we better inherit the shared functions here as well for both of them, right? What else? We need to say C hash. we are sending in a value, right? We're passing in a value to digest, right? And then all I want to do is log that to the console, where I say the winning number hash is what? Well, if it's a value, we need to store it inside of the money sign, the curly braces here, so that it tells us what's actually in there, right? So here we'll just take that value and we'll just print it to the console, right? Now, I am noticing that I did forget, I believe, to actually send these parameters to the backend, right? We define them. We didn't send them to the backend, right? We have Alice here calling for them, right? Give me those values. But we didn't here in the front end say, here are those values. And I'm noticing that mistake right now. So I'm going to go ahead and implement that as I'm talking about it, right? So that's a just Alice thing. So it goes here, right? We're going to start Raffle. It takes no arguments, right? Now, remember, I love logging to the console. What are we doing? The Raffle information is being sent to the contract, right? And then we actually need to return the object, right? So this will return this NFT params object, right? Again, this is something I should have done earlier. I just sort of slipped past me as I'm talking about cryptographic commitment schemes and how all that works. So now we've got our C hash function. Let's go back to where we were talking about C hash, right? So we've defined in the back what C hash definition looks like, right? It's a function that takes in a digest, it returns null. And then in the front end, we've actually said, okay, well, here's what it does. It logs to the console that value, right? So now that bullet point, which probably started quite a while ago here, is pretty much done. So we've selected a number randomly, or we haven't yet. Well, that's in, yep, we have. We wrote that for get num here, right? So that we can use that again in the future. Send this number from the front end to the back end. We've done that. Then use the reach cryptographic commitment scheme. We've done that to hide the value behind a hash. Then we can publish that hash and log it to the front end, right? And I gave you a little warning here because that error is going to pop up, and I want you to understand how we fix it more than get hung up on a simple import like that. So the last thing I want to do is use an unknowable to verify this information with the verification engine. What does that mean? Right? Unknowable. Right here. It says unknowable. Bob cannot know Alice's private value or salt value. Okay, we can do that. We have those values in our program, right? So right under here, where we're actually creating this hidden value, let's make a commitment to it, right? So we published the information, right? We've interacted to see the hash. We've committed to that. We've paid it into the contract, right? And then at this point, we're saying unknowable. Now this runs a check with the verification engine that B cannot know A's private winning number. They also cannot know the salt value. Remember, the salt value is important. We don't want them to know that either, right? Okay, well, that's the unknowable. This is going to check with the reach compiler that there's no possible way that B could cheat and know this value at this point in the program. Can't happen. If there is some way, based on your code, that it can happen, Reach is going to throw an error at you and ask you to fix that, right? So now we've satisfied that requirement, the unknowable, right? So that is like a quick look at what the cryptographic commitment scheme looks like. We take our value, we take that value here that we get from the front end, right? We do not declassify it, but we hide it with an underscore, right? We tell Reach, this is private, give me a private value. And then we use that private value to make a commitment and store that commitment inside of these values, right? And now we're actually going to declassify this commitment value and show that Alice is committed to these values, right? That is the highlight of really what I wanted to focus on in this program, is how we hide that value. And then once we start doing output, we'll show you what it looks like in the front end, right? Okay, so now this is done. So now let's randomly select a number for Bob, right? Pass this number from the front end to the back end and then publish. Well, we're getting good with random numbers now. And remember, getNum is already in shared functions, so we don't need to declare a new one, right? Here, getNum is declared in shared functions, so Bob can use that as well, right? So now, I guess just on this side, we just need to step through our program and how are we going to get that value, right? Well, we're just going to say, we go right here, Bob only, do a thing. Bob only, I want you to get me a number, right? And Bob's number can be public, right? Because the other number is already hidden. So this is just normal, right? This is just my num equals declassify, interact with a front end function to get me a num. And remember, we're passing the number of tickets. Now, how can Bob know this number of tickets? Well, we've published it here. So we're allowed to use it for Bob here as well, right? Now, I do want to show Bob this number too. So we're going to interact with a function that we'll call showNum, where we just pass that number to the front end so that we can see what it is. And this is very much for testing as well, so that I know if the numbers match and what my output should look like. This is going to tell me that showNum is not a function, and we know that because we haven't declared it yet. So how do we go up here to Bob? Just Bob is going to do this, right? So Bob is going to showNum, right? It's a function. Remember, it's taking in the number of tickets that we declared, right? We declared num tickets, right? And it's returning null just because it's going to log to the front end, right? So just Bob needs to do this. So it's here in Bob's interact interface, right? We're calling it showNum. It's a function that takes in an unsigned integer and it returns null. So now let's go to the front end and let's actually define what showNum looks like. Well, just Bob does it. So that's down here, right? So we said it's called showNum, right? It takes in a number, right? That number. And what do we want to do here? Well, likely, because Nick likes to log everything to the console, we just want to log this to the console. We want to say console.log. That's not the right. Your Raffle number is. It's going to be a variable or a constant. So let's put it inside of our curly braces here, and we called it num, right? So all this is going to do is show us what that number is to the console, right? Excellent. So now in the steps of our program, right? And remember your RSH files where we're actually stepping through the actions or the business logic of your program. What is your program doing, right? A only is setting all this information. We're hiding some of it, we're publishing some other, right? Then we're paying that into the contract. We're verifying that nobody can know this, or I'm sorry, just B cannot know this value, right? And then we're saying B only, get yourself a random number, okay? And now that he has his random number, or that Bob, the participant Bob has a random number, we can reveal our hashed value. Now, this is the sort of how we tie all together these hashed values. Now, I left an example in the file here. So if you have, if you want, you follow this example here, and it'll take you to, I believe it takes you to the, again, to the tutorial here, where we're actually showing, we now return to Alice who can reveal her secrets, right? And we're familiar with this syntax. It's just on different values. So let's go ahead and reveal these private values, right? How do we do that? Well, under here where Bob only is doing something, right? And to be honest, we probably want Bob to publish his number. So right here where he publishes, I'm going to include my num so that we have that, right? Step into the next part of our program. And then what? And then A only do something, right? Because A has these hash values, and now we're going to go ahead and unhash or reveal those, right? Well, remember, one was salt A, and the other was winning num, right? So first we need to declassify that value, right? And we need to store it in our own constant. Well, it's good practice just to use the same thing, just without the underscore, right? So now we'll take that private salt value and we'll store it in a regular value. We'll call the salt value, right? So now we'll say actual winning num, right? It's the same thing. It's declassify this private value that is winning num, right? Now, we need Alice to publish these values, right? So A is going to publish, and that's not how you spell publish. A is going to publish these values, the salt A and the winning num. Well, great. The winning number is out there now. We know it, right? So what is next, right? Next, we need to check that Alice hasn't changed anything, right? We do not trust anything. We create trust in our programs, right? So how do we do that? We check commitment, right? And I've included this in the doc as well that links. Check commitment takes 3 arguments. It takes your commit value, it takes your salt value, and then it takes in that number, whatever it was you were trying to hide, right? So if you wanted to check 3 different values, you have 3 different check commits with 3 different sets of arguments, where each one corresponds to the commitment, the salt, and then the actual value, right? Excellent. So what now? Well, now we want to show that winning number to Bob, right? b.interact.cWinner, right? And we'll pass in that winning num. Now, cWinner is not a function yet. We're going to declare that here in a second. But this came up in a previous workshop, and I wanted to talk a little bit about it here, just to clarify, in case you've seen this and you're not fully aware of what exactly is going on. b.interact.cWinner. But typically, when B is interacting, it's in an only step, right? This is just shorthand for this, right? So this will create an only step, right? It'll create this only thing, B only, do this thing. And it'll send your program there while you interact with whatever you're trying to do there, right? So b.interact cWinner, right? Now you can only use this shorthand if your function returns null, right? cWinner is just going to print the winner to the console. So we're allowed to use this shorthand here, right? So if I had, for example, where we're interacting up here, like, okay, or even here where Bob's doing it, let's say interact right here. We can't use that shorthand because we need to store the value in something, right? So that means we're going to go ahead and do like a whole only step. But just so that you're not confused, if you see this, it's shorthand for this, right? Okay, so now let's say what cWinner is, right? So we've done these a few times now. cWinner is also a function that's going to take in an unsigned integer, right? It's going to return a null value. Only Bob is going to do that. So we'll put it in Bob's interface in the back, and in the front, we'll say, and I guess technically I could have used show num here. So if you're like super critiquing my program design, you'll notice that I'm not following the drive principle here, where I'm giving you repeatable functions. You could probably just use that show num function, but we're pretty far down this path already. So let's just create cWinner as well. Console.log, the winning number is, and we'll pass it in that num, right? How can you use num in both places here? These variables are local, right? So when it terminates here, it'll kind of disappear. So you're not going to get a scoping issue if you use the same variable for that. So great. So now let's go back to where we were at here, right? So we've revealed the winning number, right? We've checked our commitment, right? And we're showing that winning number, right? That's what we've done so far. So now we're going to determine the outcome, right? We're going to determine what our outcome is. If Bob's number matches the winning number, transfer him the NFT. If Bob's number doesn't match the winning number, transfer the NFT back to Alice. Now, there are a lot of different ways that we can check these two numbers against each other. Do so however is most comfortable to you. I want to leave that open for you because there are so many different options for this. But we'll just, for us, the way we're going to do it here, let's go back to our backend file. And I'm sure this is going to tell me that I'm not in the right step of my program, right? This is good to get comfortable with, because Reach is going to check, are you in the right step to be doing this action? It says exit cannot be used in consensus step, must be in step. So really what we need to do is just commit here, right? So now we've got A interacting to, or B interacting to see that winning number. So now we want to check our outcome, right? So we want to say const the outcome is equal to what? How am I going to check it? Well, I love these ternary operators where I just say my num, right? That is B's number, right? My num, is that equal to the winning number? Right? That's what this is going to check. There's your question mark. Check this for me. If yes, give me a 1. If no, give me a 0. Okay. And then I said we're going to transfer based on this outcome. So then we're going to transfer, right? What are we transferring? Remember, we created the amount of NFT IDs, right? And who are we transferring it to? Well, now I'm going to use outcome to check again and transfer to the appropriate person. So we'll take the outcome constant. Is that equal to 0? Because if it's 0, they don't match. And if they don't match, send it to A. If they do match, or I'm sorry, if it is not a 0, that means it's a 1. That means the two numbers match. And we want to send all the NFT to Bob or to B, right? So here is where I've used what I'd say here is, there's several different ways to come up with an outcome, right? This is the way that I've decided to come up with the outcome. Create a constant for the outcome, compare the two numbers, store yes or no in binary, right? True or false in binary, and then use that to check for a transfer, right? You could create a function that does all these checks for you. You could create different transfer patterns that match differently. This for me just kind of was the easiest way for me to kind of look at it. So we've got that finished. The last thing I want to double check here is I include these at the bottom, display these console messages to display me these console messages, right? So log a message when the NFT is created, we did that. Log a message when you send the Raffle parameters to the backend, right? We did that as well. Display the winning number hash value, we've done that. Show Bob his number, we've done that. Show the winning number after you reveal it, we've done that. And then show each user the outcome. So that's the last part we need to do. And we've seen this. And if each user is going to do it, it needs to go in shared functions, right? So let's create the definition. What does it look like? What does C outcome look like, right? Well, C outcome is what we call it. So there's your method signature here, right? Your function signature. It's a function. It takes in an unsigned integer, right? And it also returns null. Now, remember, we make outcome an unsigned integer. We force it to be 0 or 1. So here it is in our shared functions, right? So let's in the front define what to do when we call that, right? We call it C outcome. We pass it in a number. And then we are just going to log this to the console, right? So there are two different outcomes here. There are also a couple different ways to do this. I prefer myself to create these constants. I'll do so up here, I guess. We'll say const outcome equals, right? And then here's an array that holds our two different outcomes. Remember, we're sending a 0 or a 1, right? We said that if it's 0, so index 0, I've got caps lock on, your number is not a match. Or if we get a 1, index 1 says your number matches, right? So then what I'm going to do here in this C outcome is just say console.log the outcome is, and then we're going to reference that array, right? We called the array outcome, and then we need to pass it in whatever number we got, right? And that will select 0, it'll select your number is not a match. If 1, your number matches, right? So there's where we see the outcome, right? So we've defined in the back what the function signature looks like, and in the front, what the function actually does. And now in the back, let's actually invoke it. Let's actually call it, right? So if we we use the each function. Again, I highlight that so that you know, when I say here that each, and I've got it like in gray there, like that's an actual reach function I want you to use. So we want you to come in here and say each A and B, takes no arguments, do a thing, interact with the function called COutcome and pass it in whatever we've set for the outcome. Right? Now, this is going to, again, to cover the each method here, this is going to locally show A, the outcome. It's going to also locally show B, the outcome. So when we run this program, you'll see this twice. Why do you see it twice? Well, it's logging to A's front end, and then it's also logging to B's front end, right? So that you can see both of these. Now, that is all of the bullets on the program description here. So that's everything that is included here in the level 1 description. So let's, pardon me, I didn't mean to close that completely. Let's go ahead and compile and run and see what we get. See if we get lucky. Make sure we save. Open our terminal. What did we call this? Remember, we called it NFT Raffle. Let's see what files are in there. It's got my MJS and my RSH. Now let's compile. Remember, if we compile first, this will just check our RSH file for errors. So we see that there are no failures, no errors in the backend RSH file. That means we should be able to reach run. Unless you don't set an environment variable. If that's the case, you export whichever network, right? These are the different networks that Reach supports, right? Depending on what you're trying to do on Algorand or what you're trying to do on Conflux or Ethereum. We're going to use Algorand. So we export that connector mode, and then we say reach run. Let's see if we get any errors, anything we can debug live. Okay. There's your hash value. Remember, that was a big deal for us, right? That's what the hash actually looks like, right? And then we're saying that Bob's number is a 1. Well, we know that the number's not right, even though we don't know what it is yet. And then here we are revealing the winning number, right? So likely the delay here is just from the different steps in our program, right? We're using some consensus operations, and we're also using some local steps. So if it doesn't, in your DevNet environment, like in your command line environment, if they don't line up 1 for 1, not a huge deal. It's just likely a delay in execution between the different networks, right? So we've got hello, Alice and Bob, launch our contract, right? We told it that we're creating the NFT, sending the Raffle information to the back end, and then we're showing the hash, right? This is the commitment value. This is what it looks like, right? But after, let me drag this down a little bit more. Okay, so right here is what that looks like on this line right here, line 37 now, right? Where we're saying send commit A to the front end, right? If anything changes about the commitment underneath of that, that changes and no longer holds true, right? So if Alice wanted to be a bad actor and change the number after this, we are checking that that's not happening. We're checking that these didn't change. Alice didn't do anything to these values, right? So now we come down here and declassify these values, right? We're declassifying, we're turning it away from this hash into a number again, right? So here's where we're saying publish that, and then we're sending that number to the front end. And here it is, 7. So what we did there was a very roundabout way of saying we translated the 7 first into this hash, and then we translated it back to the 7 after our actions were complete, right? We're comfortable with the commitment and the trust in our application, and we can reveal that number now. So let's go ahead and get us another output here and see, chances are we're not going to get a win, but maybe we will. And this is where I got into trouble with testing the program yesterday, is that if you really want, you can go ahead and hard code these numbers to test that your win is also accurate. right? You can hard code this number to 5 and hard code this number to 5, and then you'll go ahead and get your outcome. Is there a match? Or you can sit here and run it, 20 times until you actually get the output that you're looking for. So that is the level 1 implementation of the NFT Raffle, right? And again, the key here is that we're giving the winning number to the program before we draw any numbers. And then once we draw our numbers, we're revealing that winning number and checking to see who the winner is, right? So that is our NFT Raffle, and in the tip board challenge, as I like to call it. If you continue up through the levels here, just to briefly touch on it, you allow multiple users with an API, right? Check on the different consensus transfers. Do you need a parallel reduce here? Could you get away with a fork? Can you best implement that level 2? I leave the level 2 and 3s a little more open because I want you guys to read a little bit more and try to come up with some custom implementations for these things, right? And then each time a user comes in, you're going to store their number with their address in a map, right? Key value pairs, right? Draw until you reach number of tickets and then determine the outcome, right? There's a few other custom sets in here. And then, like I said, you start with level 1 and work your way up. If you're comfortable with level 1, go ahead and work up to level 2. Level 3 is going to be your front end GUI. We want you to build out an actual front end GUI, right? And then there's a little bit more functionality in there that's a little tougher to do. Like, could you only allow each number to be drawn once, right? But that's a level 3 implementation. We're not going to cover that here. So that is everything that I've got for the NFT Raffle. That is the entire level 1 solution there for you. So if you follow along with the video, if you sort of write the code along with me, you can submit this for level 1. So that's everything I got, and I'll go ahead and open it up to questions.